Okay, so to start off, so let's discuss the remaining transcendental functions. So let's start off with the inverse trigonometric functions. So as you can see in the given formulas, so I think these are just the opposites of your derivatives. So I think in your derivatives, you are given the inverse trigonometric functions, then the particular derivative for which is the integrand given here, right? So for example, you also have the arctangent inverse function. So the corresponding derivative of it is this one also. So also goes for your arc second. So if we try to integrate, so of course they are just the reverse of the other. So back and forth process. So in your integrals, so instead of you having the inverse function as the given equation, so you'll be determining the format first, and then the particular answer or the particular integral for the equation is your inverse trigonometric functions. So I think the tip here is you just follow the format given in the integrand. So as long as the format follows these equations, so you may be able to solve the equation using inverse trigonometric function. So take note that the a variable is a constant. And then your u function is a function of x. Okay, so what if the equation is not in the format given by the equations presented here? So of course, if we cannot follow the format, so there will be other advanced techniques that will be discussed, which I will introduce to you on March 3. So far, we'll go to the basics first. Then once we cannot approach the problem with a basic approach anymore, so that's the time that we will be dealing with advanced techniques. Okay, so for inverse trigonometric functions, you only have three formats to follow. And I think it's easy to follow since you'll only be memorizing the denominator. All right, so let's try to answer some problems. Okay, so again, if we try to write the given formats, so let's have a cheat code here first. So this will be square root of a squared minus u squared. Then the other one is du all over a squared plus u squared. Then the other one is du all over u square root of u squared minus a squared. So looking at the three formats, so what follows the given equation is the first one. So notice that it's in the format of a squared minus u squared. So a squared, so a being the constant, so this one is a squared minus u squared. Okay, so second tip here is we use a particular sub technique. So we declare everything according to the format. So we declare a squared, we get u squared, we also determine your du parameter. So by doing so is we have your a squared first, that's equal to 9. And then your u squared, so take note that we won't be dealing with the minus sign because the minus sign here is following the format also. So we leave it as is your minus sign. So your u squared is 16x squared. All right. So again, as what I have mentioned earlier, a is a constant And then your u is a function of x. So notice that your u term here has an x variable. And then your a variable is purely constant. So next, since the answer for your format is an inverse trigo, so again, if we try to recall on the previous slide, so the answer for this one is arcsine or inverse sine u over a plus c. So take note in the answer is we have a u, we have an a in the final answer. So we'll be determining the a and the u by getting the square root of a squared and u squared. So getting the square root is we have a is equal to 3. Then the other one is u is equal to 4x. Okay, so what's left for us to determine is the du parameter. So notice that we have determined a squared here in the format. You also have u squared. So the purpose of getting your u and a is for the final answer later. So you also have this one. So what's left for us to determine is the du parameter. So your du parameter is you just have to continue to derive from u squared. So starting from u squared, then you get the u, and then you get the derivative here. So you have 4 dx. All right. And then isolating your dx, so you have du all over 4 is equal to dx. So this is our value for our dx. This one is our a squared. This one is our u squared. So notice that in replacing the values in our sub technique, so we have du over 4 as our dx all over square root of a squared minus u squared. So factoring out the constant, so that's 1/4, then integral of du all over square root of a squared minus u squared. So notice that the given term here is now the same as the format given earlier in the formula. So since we have this format, simplified version, so we can automatically have the answer. So that's 1/4 times the given integral. So 1/4 times the arcsine of u all over a plus c. So don't forget to bring back the value of your u and a variables. So that's arcsine. So u is 4x all over 3 plus c. So this one is the final answer. So questions? Okay, so be mindful that you cannot cancel out 4, the 4 in the 4x and the 4 on the left side, the coefficient of the arcsine, because the 4x over 3 here is the angle of the inverse sine. And then 1/4 here is the coefficient of the inverse sine. And you cannot combine 1/4 and what is inside the angle of your trigonometric function. Okay, so you might cancel out 4 and it will lead you to a wrong answer. Okay, so next. Okay, so we have the next problem. So we have dx all over 25 plus 9x squared. So this one is in the format of the second one. So we have du all over a squared plus u squared. So again, The goal here is to um, use the sub technique to make your equation look like this one. Okay, so we're going to use the sub technique, substitution technique, subtech for shortcut lang, shortcut. Okay, so a squared. So notice again that we have a constant. So this one is our constant. So a squared is equal to 25. Next is our u squared. So u squared is equal to 9x squared. Okay, so next is du. So again, to get du, so before we reach du, so let's try to get the square root of your a squared and u squared first. So a is equal to 5. Then your u is equal to 3x. So to determine du, so we get the derivative of u. So notice that your derivative of u is coming from the line of u squared, right? So we have 3 dx. Okay, so notice that the given here is dx. So we need to isolate dx. So we have du all over 3 is equal to dx. So this term here is the one in the numerator. So notice that we have replaced every term in the given integrand as the format in the right side. Okay, so it simplifies into, so the numerator dx is equal to du all over 3 all over a squared plus u squared. So isolating or factoring out the constant, that's 1/3. So we have du all over a squared plus u squared. Okay, so again, the integral for this format is 1 over a arc tangent u over a plus c. So we have an answer. So again, don't forget to multiply 1/3. So we have 1/3 times 1 over a arc tangent u over a plus c. So we have 1/3 times 1/5. That's the value of your a variable. Then arc tangent 3x all over 5. So this one is 5, 5 plus c. Okay, so final answer is 1 over 15 times arc tangent of 3x all over 5 plus c. So this one is your final answer. Okay, so do you have questions so far? Okay, so no questions. So I hope you understood the concept. So we go to the last example. So this one is in the last format. So we have du all over u times square root of u squared minus a squared. So notice that your u squared here, so it's not a perfect square, and your a squared here is also not a perfect square. So, so despite being not perfect squares, and since it follows the format, so we still expect an answer in the inverse trigonometric function. So, so it's not stated in the rule that your u squared and a squared should be perfect squares, but um, it may be any value in the equation. Okay, so again, we're not strict to the point that u squared and a squared should be perfect squares. So it may be any other value. Okay, so notice that we have a u parameter on the outside of your square root function. Okay, now I suggest that you start first with u squared and a squared, and then we work towards your u parameter, and then next is your du. So this will be your step number one. So this case might be different from the other equations because we have an extra variable outside the radical expression compared to the first two equations. So we only have square root of a squared minus u squared. Then the second formula is a squared plus u squared. So in the third formula, we have an extra variable of u outside the radical expression. So first is we determine first your u squared and a squared. Then next is we determine your u parameter. The next is we determine your du parameter. So of course, your u and a can be determined along the process. Okay, so this one is your u squared. So we have 2x squared. Okay, and this one is our a squared, which is 10. Okay, so next step is getting the u variable. So u variable is square root of 2x, right? So notice we have x here outside. We also have x here. So this one is x. This one is also x. So for us to be able to solve this one, so you have to divide by square root of 2. So that's u over square root of 2 is equal to x. So this term here is the one. Okay? So meaning we get the value of your u from your u squared. Okay, or the outside variable from the u squared process. Okay, so again, just follow one line. So coming from u squared, then u, then if you have an extra variable of u outside the equation, so you manipulate first before going to the derivative du. So now as we get the derivative, okay, so derivative of this one is just du all over square root of 2 is equal to dx, which is the given value in the numerator. Okay, so this one is this answer here. So don't forget to also get the square root of a. That's square root of 10. Okay, so since every variable can be replaced by the u parameter and a parameter, so as you can see, there's nothing left in the given integrand. So we can now replace. So dx is du all over square root of 2 all over. So your x value is this one. That's u all over square root of 2. Then square root of u squared minus a squared. So we can cancel out square root of 2, square root of 2. So what's left is the basic formula of du all over u times square root of u squared minus a squared. All right. So again, by answering the equation, so by formula, so that's 1 all over a arc second u over a plus c. Okay. Then bring back the value of your u parameter and a parameter. So you have 1 all over square root of 10 arc secant. So your u parameter is square root of 2x all over square root of 10 plus c. So this one is not yet the final answer because we still have to simplify your radical expression. So if you recall your topic for radical expressions in algebra, so it's not need to look at if you have a radical expression in your denominator. So we need to rationalize. So again, the term here is rationalization. Okay, so you multiply by, so this one becomes square root of 10 all over 10 arc secant. Then this one is square root of 20 x all over 10 plus c. So notice in the angle is we can still simplify your square root of 20. So this becomes 2 square root of 5 all over 10 plus c. So again, this one is 2 square root of 5 because we have 4 times 5. Then since 4 is a perfect square, so we take it outside the equation. So we have 2 square root of 5. So we can cancel this one out. So the final answer is square root of 10 all over 10 arc secant square root of 5 all over 5 plus c. Okay, so this one is your final answer. Okay, so questions or clarifications? All right, so I hope you understood the topic. So again, the main objective here is for you to follow the format of your inverse integrals, inverse trigonometric integrals. Hmm? Nabre x day, na x day, sorry. So we still have an x variable here. So thank you for that one. Okay, so far okay na siya? So do you have any confusion for the inverse trigonometric functions? Okay, so I think there's none.